Today is November 3rd, and I just sent an email out to everyone, parents and students, regarding this coming week. So you're going to have at least two grades that will be available. One of them will be a new grade on Tuesday. That's going to come from the stuff we've been doing with parallel and perpendicular lines, has to do with slope, creating an inverse slope. I'm not talking about that in this video. This video is only for the retake, which the retake or the makeup, because a lot of students missed that quiz. You weren't there because of testing, and a lot of you haven't come in and take it yet. I mean, a lot of you haven't come in and taken it yet. So you have 1 week. And I told you if you take it on Monday, then you should have still time probably for a retake. If you don't take it Monday, you might not get a chance to do a retake on it. So hopefully you see this, hopefully you practice, hopefully you take it on Monday. I'm just going to go through some of the IXL. Every question comes from IXL, so this is that quiz. I am literally not changing the words in anything unless I make it easier or unless I just have to change the format, but it's the same exact questions. So this particular IXL here is JUU. There it is right there. You can see JUU. I'm in IXL. I'm not in my smart notebook thing, so I'm going to be a little limited on what I can show, but I can at least walk you through the logic. So I'm not going to do a full long lesson. You can go back to the class lesson on truth values for that. I don't know the date on it. You'll have to go back and look at it. We've done this for a long time though, so hopefully by now you should have it down. You just need to practice. So the first thing is we need to know what that squiggly guy means. So if you notice up here, there's the squiggly guy in front of the statement. The statement is just S. We don't know what that is, but we don't need to. We just need to know what the truth value of that statement is. So if we know S is false, statement S is false, we said the negation symbol, so I'm not supposed to say squiggly line, but the negation symbol looks like that, or a little flatter sometimes, or like that. That means that you are creating the inverse of the statement, sort of. Statement doesn't have to be an if then, but you're basically putting the word not in it. Or if the word not is already in it, you're taking it out. So if I say Johnny is wearing a hoodie, the invert or the negation would be Johnny is not wearing a hoodie. If the statement is Jenny is not going to school, the negation of that would be Jenny is going to school. It's not always that easy, but it pretty much is in IXL. You either take the word not out of the statement or you put the word not into the statement. So when we create a statement and we don't know the statement, we said there is an extremely important concept that whatever the original statement is, and we did this in class, I'm not going to do it again, whatever the truth value is of the original statement, so if S is false, when we create the negation of it, sort of the inverse of it, when we put the word not into it or we take the word not out, we're creating the opposite truth value. So it flips the truth value, always, no exceptions. Whatever the original truth value is, putting that negation symbol in front of it flips it. So if I already knew truth value, which I do, it's false. So just kind of going from here down to here, S is false. Well, that means I need to flip the value of that false. That's what that symbol means, basically. Change it to the opposite truth value. So this answer is true. The original statement was false, but when I put the negation symbol in front of it, it flips it to true. And I'm probably going to just skip to the higher levels. Yeah, that's too easy. All right. So now, and I didn't put one, I'll just tell you this is not on the quiz, but I still want to do it. So P is false. So statement, I got to click on it again. So statement P we know is false. Tells me that right there. Well, tells me that right there. So I could say, and here's what it looks like. All right, well, statement P is false, so I could write that. But then I have this first negation symbol there. All right, well, that's so I'm kind of bringing that down. You can do this in pieces and it works fine. Just don't forget a piece. So that symbol tells me I need to flip it to true, but then I need to bring the second symbol down. Well, that symbol now tells me I need to flip it back to false. So the final answer for that is false. So it kind of is like those two symbols just cancel each other out. It flips it once, but then it flips it back again. So that's false. Again, that's not on the quiz, but we did see it in some other places. All right, so here's what we need to know, or something new we need to know. These symbols, we said, create compound statements. This and that. Johnny is wearing a hoodie and Jenny is not going to school. So it's two smaller statements joined together to make one statement, sometimes more than two. So if okay, just forget that. That symbol there and that symbol there are the two that you need to memorize, and you should have them down. We've done it for a long time. So, and joining it with the word and, we said is easier to remember because that symbol sort of looks like we're starting to write a capital A. If we just put a line through it, it would be a capital A. So if I said Johnny is wearing a hoodie and Jenny is not wearing I'm sorry, Jenny is not going to school, whatever it was, I would join them together with that symbol if I were going to use letters to represent the statements instead of writing the whole statements out. Now, if I was to say Johnny is wearing a hoodie and I'm sorry, or Jenny is not going to school, then we would use this symbol. So here's what you need to know. When you're finding the truth value of a compound statement, so two statements joined with either the word or the word and, there's just really a rule you can memorize. I would prefer that you understand it and why it works. So if you think about it, this or this could be true and the whole thing is true. Well, that means either one of them could be true. If I say this and this are true or have to be true, really, that means both things have to be true. But if you didn't get that, we've done a lot in class. So I'm going to go ahead and move forward and just give you the shortcut. If it is an or statement, you only need one true. You can have two true values. Two true values still works, but you only need one. If you have at least one, then the whole compound statement is true. So you need at least one true for an or statement. That's an O. At least one T, that's true. For an and, you need two trues. They both have to be true. If they're not both true, then the compound statement, we consider it to be false. You'll see as I go through it, I think, too. All right, so I'm going to get rid of all of that. If I can. Oh, I hate the screen. Hold on. Let's do it a different way then. There we go. All right, so now we'll go back up and I'm just going to do a bunch of them. If you need more than that on the lesson, we did that for probably 3 days off and on. So you can go back and look at, and then we even had an exit ticket on it a while back. So just look for truth values. Probably was with other stuff, but truth values should be in the video I posted. All right, so I do this one at a time. I do not try to do this. So I'll just rewrite the statement. P or, so that's an or symbol, and then Q, that's parentheses. And then now I have an and statement out here, Q. Now, if you haven't taken this at all, or I guess if you're retaking, I did say sometimes there's a shortcut because out here I see I have an and statement already. So this symbol out here is and. I wish I would have done it. Should use the mouse. I'm going to just leave it there. I'm not going to try to keep going back and forth. But this symbol tells me and, which means in order to have a truth value of true for this whole statement, again, all of this, I'm trying to figure out what is the truth value of this entire statement. It's joined 3 different statements together. I would, at the very final step, I need two true values because of this thing I have circled. That's an and, which we said means I need two truths. So that's kind of where I'm working my way. Well, in order to start, I know Q is true, so I know I have one. I could actually even write true there if I really wanted to. You can write the value of all of these at the very beginning if you really want. So I could say, okay, well, I know that's true. Let's see, P is false, tells me that right here. So that's false. I have the symbol. And then Q again, Q, it's the same Q. So if it was true once, it's true again. So this is kind of my compound statement, but with all of the truth values put in. I only compare them two at a time. I do not try to figure it out all with three or four or more, because sometimes there can be more. So I look at what's in parentheses. So I just kind of ignore this outside statement for right now. Just ignore that. I need to know, what is the truth value in here? Well, we said if it's an or statement, which it is, that symbol means or, I only need one true value. And I have that. I have a true value right there. So in parentheses, I have true. Now I can bring in the other truth value, the other statement, and I have that. Well, we said for an and statement, which is what this is an and symbol. I need two true values in order to get a true, and I have them. I have a true value here, a true value here. So the overall value is true. That's what I'm gonna do. I'm gonna do them a lot faster now. So I look at this. This was one that actually is similar to the quiz. And I say, okay, well, I need to figure out what is the truth value. Oh, I hate that. I'm going to leave that there. So I have the negation symbol, which will, at the end, that's going to flip whatever value I come up with. So don't, a lot of kids miss that. So that and that. All right, so that means I need two true values in the parentheses in order to get a truth value for that compound statement in the parentheses. Well, let's see. Q is true, so I'll write a true there, but R is false. Again, I do not have two values of true, and I need that since it's an and statement based on that symbol. So this is an and statement. All right, well, if I don't have it, then that means that's false. But don't forget, I need to still take into account that I'm negating whatever truth value. I'm changing it to the opposite, whatever I get in the parentheses. So that means this actually changes to the opposite. All right, so now can I zoom in? Oh, actually, I have to probably do this first. Yeah. All right, so I'm just going to start doing them right in the problem. P is false, Q is true. So that's false. False, true, Q is true. All right, so now I look in the parentheses. In the parentheses, because I'm comparing two statements at a time, never more than two at a time. And I always start in the parentheses. That's an and statement. I need to get two true values for this whole thing. Oh, hate it when I do this. It's faster, but it's annoying. So I'll just circle this whole thing. So that statement has a false and a true, but in order for that statement to be true, I have to have two truths because of the and symbol. So the and symbol is this thing again. Hopefully that, yeah. So I do not have two truths. So in the parentheses, that gives me a false. That's supposed to be an F. Oh, all right, I'll put it out here. I can't write very small with my finger. That's a problem. So now I have to bring in the other statement that's outside the parentheses, this part right here. So I have a false statement, and then I have the symbol for or, and then Q is true. So for an or statement, I only need one true, and I have it. So the overall value of that is true. So that statement should be true. Let me get the pin back. Let's see. I'll just keep working on them. It's gonna take a super long time. So these are both ors. There's an or symbol in the parentheses and outside. So let's see. False, S is true. Oh, I don't know why I did that. Ah, so S is true. R is false. So R is false again out here. So inside the parentheses, I only need one true because it's an or statement, and I have that. So I have F and then this symbol, and then in the parentheses, I had a true. So all I did is bring down this first part here. I just brought it down. Well, now I still have an or statement, and I only need one true, which I do. So that's true. All right, good. Now here's a negation. All right, so again, negation means I'm flipping the sign. So I have Q, which is true. It's an or symbol. I have R, which is false, but I need to flip the sign of R. That's what this means. Flip the sign of R. So if R was false, the negation of R is true. And then I only needed one true, but two trues works also if it's an or statement. So that would still be true. Oh, by the way, you should be pausing these and trying to do them on your own. I should have said that. So try to do that on your own. Pause it. I'm not going to pause myself because you'll come back when you're ready. So now inside the parentheses, I don't even know if I hit the pin symbol or not. P is true. Yeah, I did. Q is true. It's an, actually, that would, if I have two trues, we said this in class, it's automatically going to be true because two trues works for an and statement or it works for an or statement. So anytime you have two trues, the compound statement's going to be true. So I have the symbol still outside though. So that means, okay, well now when I bring the symbol into play, I need to flip it to false. So hopefully you got that one right. Man, we're only on level 2, but we're already at 78. So the levels must go up fast at the end. All right, so let's see. This is kind of similar to what we had. Try to do it on your own. But like I said, if S, so you should be back. If not, pause it and do it. So S is true. Well, the first symbol will flip that to false. But then I still have one left. I have two of them. So that flips it to true. So it kind of just cancels them out when you have two of them. Still on level. There, now we're finally on level 3. All right. So, and they don't really get that much harder. I have an and symbol, so I'm going to need two trues. I like thinking about what symbol do I have first sometimes. So I have R is true, but again, if I'm negating R, try to turn that off. So I'm negating R, I'm flipping R. So if it was true, the original was true, the negation is false. Well, F is false, but I'm negating that. So again, it's got the negation symbol. And it says over here, the original was false. So I'm negating that, which means I'm flipping that to true. But it's an and symbol, which means I would need two trues, and I don't have two trues. So it's false. I'm not going to use the pin anymore. That's driving me crazy. I'm just going to walk you through it. All right, so First of all, I look in the parentheses. All I need is one true value because I have an or symbol. So if Q or S are true, what's in the parentheses are true. Oh, I should have try to do it on your own. I just gave you half of it. So Q is true. So Q is true, which is all I need is one. S is false, but again, that doesn't matter. So inside the parentheses, you should have gotten a true. Now, though, it's an and symbol. So I need a true, which I got, but R would also have to be true, and R is false. So that is a false statement. I did not have two true statements. All right, so man, I wish they'd have more negation symbols, but all right. So again, I start within the parentheses. I just need one true. That's an or, so either of these could be true. R and R is true, so there's the one true I needed. P is false, but it doesn't matter. So I get a true value in here. But now I need two true values because of the and symbol. So Q would have to be true. This is true in here, but I need Q to be true, and Q is not true, which means it's false. I only had one true, and I needed two of them because of the and symbol. All right, so try to do this one on your own. Pause. Oh, here's a better one. So now, inside, I have an or statement. I only need one true, but I also have to remember that I'm flipping the sign of the original statement R. So R is true, but I'm flipping it because of the negation symbol. So this is actually a false value here. Q is also false. So if you have two false values, it's always false. There's no exception. You need at least one true, even for an or statement. So inside the parentheses, I have a false, but don't forget about this that is outside. Now I have to consider this negation symbol. So if inside was false, I need to flip it to true. So this is true. All right, so now this one's a pretty easy one again, it looks like. So inside the parentheses, I have an or statement. I just need one true. Well, there's my one true. P is true. R is false, but it doesn't really matter. I just need one. So inside this, I think this is the same exact one we did a little while ago. You see the same ones over and over again, like if you practice enough. That's why I told you guys you should do well on these quizzes when I pulled up from IXL. I'm pretty sure we did the same problem earlier. So now that I know inside here is true, I need another true because of this and symbol. Well, Q is not true. So that means overall, this whole compound statement is false. I can't, are we on level 4? Oh, here we go. This must be level 5 then. So level 4 didn't even get any harder than level 3. All right, here's one that is a little tricky. You can do these, you're probably in good shape. All right, so I start in parentheses. I have to remember the negation signs will flip the original truth value. Well, R is true, which means this is a false value here. S is false, which means this is a true value here. So I have one false here, one true here. I have an and symbol, so I needed two trues. So inside the parentheses, and I don't have that. I have one true and one false. So inside the parentheses is false. But I need to then take into account this symbol outside. So if inside is false, this is going to flip that to true. That was what a lot of kids missed on this part of the quiz. They didn't take into account the negation symbol outside the parentheses. All right, so kind of similar, actually pretty much the same thing. So this is going to flip, this negation symbol will flip whatever R starts at. So R starts at false, so that is true. Q starts at false, so this is also true. It's going to flip that. So inside the parentheses, I have a true and a true. Well, that's two trues. That means it's always true. And statement or statement doesn't matter. So inside the parentheses, this statement is true. But now I have to bring this into play, so it flips it from true to false. This might be the last one. Brackets are not on the quiz, but they're just parentheses. It just means we'll do them before we do what's outside this thing. So inside the parentheses right there, I have an or. So I have a false and a false. Well, false and a false is always false. I need at least one true. So this is false, but now I bring into play the negation. So that flips it to true. So this is now true. It's an or statement. So really, I already have a true value. I don't even really need to look at what P is because this was true right here. It was false in here. This flipped it to true. I only need one true. So now in the brackets is true. But then I come out and bring this into play, which flips it to false. Oh, no, we got one more left. I score. Now this may be the last one. All right. So again, this is false. Well, I really don't even need to keep going because it's an and statement. And in an and statement, I need two trues, and I already have a false right here. So I know it's false. But just to go over the last part, I need to change the original value of Q. Oh, this is why it's at the end. I was going to say this is a pretty easy one. It's actually not. We need to know what Q is. There's no information on Q. Actually, no, we don't need to know what Q is. I take that back because we already know it's false. So a lot of kids would probably say they cannot determine it because they're like, oh, well, they didn't tell me what Q is. Well, we don't need to know what Q is. I need a true value here and a true value here. Well, this is already false. Like it tells me that right here. P is false. So if P is false, then this whole thing is already false. I don't need to. So that was a tricky one. Oh, I am still not done. All right. So let's see. This is an and statement. So again, it's kind of the same concept. I need two true values. Well, they're already telling me R is false. So it doesn't matter what Q is. If Q is true, this statement is still false because R is false. And I need two true values. So I don't even need to know. So those are a little trickier. I thought I did see one time where the answer was you cannot determine, but maybe I was wrong. All right. So now I get back to, I'm just going to go into, well, I got to go fast. I don't really want to go all the way up to 100, but what was the other N5P? So there were a lot of topics from this. I'm not going to topic. Um, I don't want to make this an hour and a half long. So if it is a converse, so again, this is just a matter of you putting some time in and memorizing stuff. That's all it is. If you memorize it, you do enough of, I mean, I'll reset it again. So if you get to 100 and you want to keep practicing to make sure you do well, I'm going to be resetting it throughout the week. This is a converse. You need to know what converse means. It means you are switching the order. Oh, I knew I was going to do that. This wording will not change at all. It is just flipping order. This wording, oh, hate it when it does that. This wording will not change at all. Converse is the only one where the wording doesn't change. They just switch orders. In the other two, we're in an inverse, we're either putting the word not in or taking it out. In contrapositive, we're putting not in or taking it out. So converse is the only one where the wording doesn't change. So just look for one, at least for these IXLs, look for one where the wording doesn't change. There shouldn't be the word not in here. There shouldn't be the word not in here. Well, there's the word not, so it can't be that one. There's the word not, can't be that one. So that's another way to do these. Just make sure you know for sure what converse means, like that there's not, you don't change it, you just switch the order and you can do it that way. But the real way to do it is I take this part in the back, he takes a vacation, and I move it to the front. He takes a vacation. I take this part in the front and I move it to the back. He gets a raise. So that's what you do with a converse. You switch the order. Nope, I didn't actually answer. Same thing. I'm not going to keep going through those forever. I mean, I guess I will. just the three that are the three different ones. Contrapositive. This is the one where you do everything. The wording changes and the order changes. So it shouldn't look anything like the original. You shouldn't have the same statements in it. You shouldn't have the same order. Nothing should be the same. So if I see vegetable soup stuff in the beginning, it can't be that. Well, here's vegetable soup. It cannot be this one. The order has to change and we have to change the wording. So if I see one where the wording doesn't change, so if it says not feeling well, that can't be right because the wording has to change. We change everything in contrapositive. So if I see one where it says here's not feeling well, can't be that. The wording has to change. Now, if you do it the other way and you say, okay, well, what do I do when I make a contrapositive? I change the order. So I'm putting this. I'm not very good at using mouse. Not feeling well should move to the front. Well, here's two about feeling well. Right. So again, it should be one of these two. Not feeling well isn't there. Now I just have to say, okay, I should also make the negation of that for a contrapositive. So not feeling well, negating it means take out the word not. So is feeling well would be the one I select. I really don't even have to look at anything except for one of the two statements. Like if you just take one of the two statements, it'll work every time on all of them, converse, inverse, everything. At least in IXL. That's only for IXL. It's possible on the EOC, they could make it more difficult. But all right, so here we go. Helen is at the video store. Oh, wait, we're doing a contrapositive. So it's the same one. I'm just going to do it. So this wording has to change and it has to move to the end. So I should be looking for Helen is not at the video store at the end. Well, that has nothing to do with not at the video store. There we go. Not at the video store. Just to make sure I can look down here. Well, that says she is at the video store. So it's got to be this one. That's the only one where this went to the end and they negated it. So I don't even really need to look at the second statement in IXL. Again, could have to do that though in an EOC, so it's better to understand it. Oh, they keep giving me contrapositive, so I'm gonna do the same thing. So she is shopping for celery. Well, I need to move that to the end and negate it. She is not shopping for celery, should be at the end. Well, that's about the farmer's market. That doesn't negate it. Oh, there you go. She is not shopping for celery. I need an inverse. Oh, here, I'm just going to miss it. I hope I miss it. So I can try to get an inverse, hopefully. I don't want to go to the next level yet. Ah, give me an inverse. I'm just guessing. Probably, got it right. Did not want that. Man, they keep giving me the... I'm not sure why I cannot get an inverse. This is the long, there we go, finally, inverse. All right, so inverse. Inverse is the only one where we do not switch the order. We switch the order in converse, we switch the order in contrapositive. So if I just look for this eating pecans part at the beginning, it's got to be, at least in IXL, it's got to be inverse. Because in all the other ones, they would put pecans at the end. Inverse is the only one where this will stay at the beginning. Now, I can also make sure that there's the word not in there because this said she is going to. So it needs to say is not going to, and it needs to stay at the beginning. Well, it's not at the beginning here, so that can't be it. Not at the beginning here, so that can't be it. And here it is at the beginning. Eating pecans at the beginning, and they did put a not because that's what an inverse is. You either put the word not into the statement or you take the word not out. So you'll notice over here, this part will still be at the end, but it will say it is Thursday. They're going to take the word not out. And there you go. It is Thursday. That's what an inverse is. I should have been making you try these. I didn't think about it. All right, so now I'm going to skip to the next level since we finally got an inverse. This one's really simple. It's the same thing we just did. Instead of choosing from a list, though, they give you two statements and you have to say which one it is. So if it doesn't switch orders, that has to be inverse because inverse is the only one that doesn't switch orders. If the wording doesn't change, then that has to be converse, because converse is the only one where the wording doesn't change. So those are some tips also, but let's just see what happens. Nina is going to serve onion rings. Well, onion rings moves to the back, so it switches, and this says it is not going. So they switched the order and they negated it, so that's contrapositive. That's what contrapositive is. So you try to do the next couple, and then I'm just going to answer them. So you should be back. You should have paused it. Let's see. So a lot of kids were getting, it does not matter what's in the original statement. It doesn't matter if the word not is in there. Doesn't matter if the word not isn't in there over here. You're just determining how did they change the original. Don't worry about what the original is. I think some kids were trying to figure out, well, based on the original, it's got to be converse. It doesn't matter what the original is. The original could be anything. So you're just trying to see how did they change it. So how did they change it? So egg drop soup for lunch moves to the back. So it's either converse or contrapositive. I know that for sure. Now I just have to see, did they negate it? Did they take the word not out, saying she does have egg drop soup? They did not do that. They still say does not. So if it just switches order, that's got to be converse. So I'm going to let you do the next one. Try to do that one. And then I'm probably just going to skip to the next type of problem. I don't even know if there's another one. All right, so you should have tried on your own. All right, so Peter is not at home. So let's see where that is. Well, that's in the back. So it's either converse or contrapositive, because those are the only two that switch. It said he is not home. Here it says he is home, so they actually negated it. So it's that one again. So again, same thing. Let's go to the next one. Oh, and these were not on the quiz. I'm not going to worry about those. The best way to do these, you could see these on the district though, for sure. Write them out in words. So, and you need to understand the symbols. If T is less than 7, then T is less than or equal to 7. And you have to understand whether or not that's true, which is a little tricky. That is a false statement, though. That is not a true. Oh, it says is the contrapositive. So we have to flip it around. I'm going to do this one. I'm not going to do them all. So the way that I would do this, it's just really tough to write on the screen in this app. So I'll just say it in words. So in words, the contrapositive would be putting not into this. So if T is not less than or equal to 7, then T is not less than 7. So that would be what you would write first. It'd be so much easier if you could see this, but maybe I'll do this in class or in another video. But so now I have to think about, well, what does it mean if T is not less than or equal to 7? Because that was the first part of the statement I just made for the contrapositive. Well, if it's not less than or equal to, T has to be greater than. So if T is greater than 7, so the second part would be then T is not less than 7. So that would mean then T is greater than or equal to 7. So that's, again, without showing you in words, that's kind of tricky. But this is just for the quiz, so I'm going to keep moving on. And that was it for that IXL. Let's see, we did N5P, so what was the other one? Oh, Q6E. I kind of went over this one in class. One part that you'll see now. So the first few, I was confused because I thought we were trying to figure out if they were true or not. It has nothing to do with if they're true. All you're looking for is that statement, if and only if. When you see if and only if, that's how you write a biconditional statement, assuming, that the statements are true. This is just a normal conditional statement. If this happens, then this happens. That's just a normal conditional statement. So when it says, is it biconditional? The answer is no. And these are not on the quiz. That's why I'm just kind of moving through them. So again, if this happens, then this happens. That is not biconditional. That's just a normal conditional statement. So if this happens, then this happens. That is not a biconditional. You'll see when I get to a biconditional what it is. Here it is. So now it says Elijah is bidding if and only if. That's what makes it a biconditional. That implies that the converse is also true when you say if and only if. Again, some problems will have you determine whether or not the statements are true. These you're just assuming that this Eli bidding part and this auction part are true. So it can get a little confusing, but for these particular ones in IXL, if it says if and only if, then yes, it's a biconditional. That's the wording of a biconditional. I think the book had some that had that in it, but they were not true. So like I said, the book and IXLs don't always match. In this one right here, what you're doing is you're basically creating two statements that would be a biconditional, meaning that they are converses of each other and they're true. So you'll see what I do, I think. And it's based on this. So I need to have this. I can't change these around. Like 4u plus 9 equals -9 has to still be 4u plus 9 is -9, like right there. 7v plus 9 equals 4 has to still be 7v plus 9 equals -4. So that one would be one of them. And then the other one would be the converse of that. So 4u plus 9. Yeah, that one right there. So those are the two correct statements because if you look at them, they're the converse of each other. And they're based on this original statement. It looks like they didn't change. I was just reading. I don't think they changed. Oh, yeah, they did change. So here you see this 9u subtract 9. That's not either of these statements. You can't change these statements around. You can't make a change to the statement and have it be a biconditional. All you can do is make two statements that are the converse of each other based on these exact statements right here. So this one is the same statements, but they didn't make it the converse. What did they do? Oh, yeah, they switched. I'm sorry, they switched the order. 7v plus 4 equals 9 instead of 7v plus 9 is 4. So that's why that's not one if you're confused. So if you look at these two statements I've highlighted, they're the converse of each other, and they use the exact same statements as in this original. That's what makes it the answer. That's not on the quiz, though. This is what's on the quiz. You have to know how to choose the two correct statements, kind of like what we just did in a way. I need to find the two statements that are converses of each other, exact converses of each other. So I just look for, and you may have to go one by one. If I can find a statement where 9r subtract 1 equals 7 is at the beginning, and 4q plus 8 equals 1 is at the end, that's the correct answer. I need to find there, and there will only be two converses in here. There's not more than that. Like you can't find 4 statements or 3 or anything like that. So let's see, 9r subtract 1 equals 7, 4q plus 8 equals, nope, that's not it because 8 is at the end and 1 should be at the end. So that's not it. 9r plus 7, so that's not the same statement. So there is no converse for this. There isn't one. So that can't be it. I'm pretty sure it's not this one because I didn't see a lot of statements with here's q plus 4 equals 8. So that is the same statement there, but this would have to be the same statement at the beginning. 9r plus, oh, actually it is. So here you'll see when I highlight them, I think. So look at those two statements. Those statements are the converse of each other. That's what makes this the correct answer. There's no other statements you can choose out of these 6 that are the converse of each other. There will always only be 2. So just make sure when you choose the two you think are correct, just look at them and make sure they're the exact converse of each other. Make sure the statement wording or the numbers or the variables, make sure they haven't been switched around at all. Has to be the exact same as the two statements that you choose. Q plus 4 is 8. Q plus 4 is 8. 9R plus 7 equals -1. 9R plus 7 equals -1. Every other one changes those individual statements in some way. Like here, 4Q plus 8 equals 1 instead of Q plus 4 equals 8. 9R or 7R subtract 1 equals 9. Well, that's not the same as 9R plus 7. Plus, they're not flipped. So just again, choose two, make sure they're the converse when you check your answer. And you'll see that's right. I'm not going to continue to do those. You can practice all of those. That's not on there. I think I'm going to jump a level. Oh, here's some where it says if and only if, but it can actually not be true. You have to go through the logic and figure out if the statement is true, I believe. I don't think this is as simple as just saying, oh, well, it says if and only if, so it must be a biconditional. See, they're trying to find, they're not asking you if this is a biconditional, they're asking you if the biconditional is true. So you would have to create two different statements, like break this out kind of like we did in that other one that I showed you. What are the two individual statements that are converses of each other, and then determine if they're both true. Those were not on the quiz though, so I'm just going to skip to the one that was here. This is on the quiz. So if this biconditional is true, that means when Q equals 10, 2 would equal 4Q plus 6. Or that if 2 equals 4Q plus 6, Q would have to be 10. That's what makes it biconditional. Both things are true if I flip them around. Here's the short version. Just plug the number in and see if it works. If you plug 10 in and you get the correct answer, then it's biconditional. The answer is yes. 10 times 4 is 40, plus 6 is 46. Well, that doesn't equal 2. So that's a no. And there's quite a few of these, so just... Now you could also solve on the left and see if you get 4, and that would work as well. So that's again kind of why it's biconditional. I can either plug 4 in, or I can solve and get 4. There's two ways to solve it. It's biconditional. Plugging in, I think, is easier. 4 times 3 is 12. Subtract 9 is 3. So that's a yes. That is biconditional. So you can try to do those on your... Oh, the ones... No other ones are on the quiz. Just the ones where you plug in and you solve. I'm going to try to do this one just... Oh, that's a good definition. I don't really even understand these. I didn't read through them. An apple is a fruit that grows on a tree. Like, I don't know what they're trying to get to on that, I'll be honest. And I didn't even try to do them to figure it out. I don't know how that's about biconditional. Maybe a fruit that grows on a tree is an apple. So they're saying the converse is not true. So it's not a good definition. I don't know. Let's see. Yeah. So I guess that's what they're saying is it's not biconditional, basically. They're saying a good. So yeah, this would be a yes. Because if I flip it around and I say a polyhedron with 6 faces is a cube. Well, actually, that's not true either. Yeah, I don't think that would be true either. Oh, I don't know. I don't think it has to be regular size faces. Oh, yeah, see. So, no, that actually that would be no also because there are other quadrilaterals that have congruent sides that are not rhombic, like a cube. So that would be a no. So they're basically saying, is the opposite true? If you write the converse, is it true? And if it's not true, then they say, no, it's not a good definition if you want to go through those. All right, so that was the 3. I'm not going to do the last IXL. It's already taken too long. I'll just show you one thing. This is a separate grade. This is the transversal parallel lines. Oh, actually, here, I have this, and this I can do. A lot of people are still struggling to see or to understand when you set things equal and when you add them together and equal 180. It's just practice. You need to practice that IXL RSV. I'll show you one more time the cheat sheet version. If you number them like this, 1, 2, 3, 4. Make sure you memorize that. I still saw people get that wrong. They tried to do it this way, but they numbered it wrong. They didn't memorize it. You have to put time into this stuff. 5, 6, 7, 8. If you get that down, and I would only do these in ones where you're trying to solve. If they've already put numbers in and they've already labeled them similar to this, I wouldn't try to use this method. That's when you got to understand vertical angles and linear pair and alternate inch. I mean, you could try to still use this if you're really struggling, but right now, we said every even angle is the same measure. So any two even angles, you would set them equal because all the evens are the same number. All the odds are the same number. So if you have two odd angles, you would set them equal to each other. If it's one odd and one even, so I'm down on this bullet point now, that's when you add them together and set them equal to 180. So again, I'm just going to move stuff around. I'm not even going to do the algebra. You got to know the algebra. So if this was there and this was there, that's two even angles, 2 and 6, right? Oh, and the even and odd stuff doesn't come from these. Like, it doesn't matter what's in this. It doesn't matter what's in here. That has nothing to do with when I say even or odd. Even or odd comes from here, where the angles are located. So some kids were thinking the even and odd came from inside the expression itself. That means nothing. The even or odd comes from how you number them right there. So again, if I put them here, whoop, didn't mean to do that. They're both even, right? 2 and 6, angle 2 and angle 6. Well, if they're both even, I would set them equal. 10x subtract 21 equals 6x plus 25. And then you have to solve for x. Make sure you read the question. Some kids solve for x, but didn't go back and find the measure of the angle, which is one of the questions. Now, let's say I moved them. Let's say I put one there and one there. Well, now they're both odd. Well, two odd angles are also set equal to each other. That's angle 1. Like this is angle 1. This is angle 7. Well, 1 and 7 are odd, so I would set them equal to each other. Now, if I moved them down here, it's angle 3, and this is angle 6. Well, that's one odd, one even, 3 and 6. That's when I would add them together and set them equal to 180. One odd and one even is when I would add them together. So it would be 10x subtract 21 plus 6x plus 25 equals 180. Then again, solve for x and read the question and see if you need to plug x back in and solve for the angle. So the angle is just to show you, if I did need to solve for the angle, this would be the angle I would be solving for if it was the 6x plus 25. So, and you just follow the letters that I give you. Like that's how you name an angle. You just follow the letters. That tells you which angle. This angle here would be the 10x subtract 21. So again, I don't have any. Do I have any with letters on it? That was the very first thing we did for the year. So if you still don't remember how to name angles, you need to go back and watch that. There's probably IXLs you could also do. I don't see anything there. Yeah, that's recent stuff. Oh, so here's what I was talking about. When they number them, like, oh, actually, they did number them 1, 2, the way I number them. Normally, they don't do that. That's funny. Normally, they number them. Let's see if I can find one where they numbered it the other way. Don't. Oh, you see, this is what I'm talking about. There, they say the measure of angle 3. So they want the measure of angle 3. Oh, no, they don't. You're just solving for x there. So scratch that. Let's see. So we said the only two options, either you set them equal to each other or you add them together and they equal 180. Visually, if you can tell, I mean, I know this angle right here is a fat angle. So it's got to be equal to that fat angle. It can't be equal to a smaller angle like the 2x plus 6, but if they look like they're the same, then you set them equal. There's no way those two angles added together is 180. They're both bigger than 90, so they've got to be bigger than 180 if I add them together. I can also look at these two. First of all, they're vertical angles, so I should kind of know that. That angle is a skinny angle. It has to be equal to that angle. If I look at a skinny angle and a fat angle, so let's say I looked at this angle and this angle. Well, they're clearly not the same measure. One is way smaller than 90, one is bigger than 90. Well, if they're not the same, then they would have to add together and equal 180. I don't see any, oh, there's a truth value problem I could use. I didn't know I had that in here. So that's the way you normally see them numbered, 1, 2, 3, 4, 5, 6, 7, 8, like that. I'm kind of surprised. Well, that's the way the book does it, at least. And I think IXL. Yeah, I do not have anywhere it show. Oh, here we go. So you see how they're asking you for angles down here, and this is not the same kind of problem, but just if you're trying to figure out which angle they're talking about, you go follow the letters. Angle ADB is this angle here, from there to there, and then from D to B. That's the angle. And remember, we measure angles down in the little tiny, what didn't mean to do that? Down in the little tiny corner. Whoop, there we go. We measure them in the corner, so it doesn't matter what happens. Like this is the measure of the angle down here. That's where we measure the angle. It doesn't matter how long we extend those lines out or how fat it looks way out here. Like a lot of kids, I think, are still thinking that this area out here matters. Like that area out there means nothing. I don't care how fat the area is out there. I don't care how fat the area is out here. That doesn't have anything to do with the measure of the angle. That just means one might go on for farther out. The measure of the angle is down in this little corner. If you use a protractor, that's where we measure, down in there. You put the protractor right here and you line it up with the two, whatever two lines you're using to measure the angle. So don't worry about what goes on way out where the blue space is up there. A lot of kids, I think, are still confused by that, which that's not part of geometry. That's something that you are supposed to know. So if you're confused by that, you need to go in and do those old IXLs. And I'll give you more. If you're struggling, you got to let me know. There's plenty of IXLs you can practice. Just look up videos on just the basic stuff about angles. All right, so that's all I'm going to do. It already went away. Wanted. That's just for the retake. Has nothing to do with the Tuesday quiz.